Hello everyone, my name is Fatima Mohammad Attarwala from the College of Home Science Nirmala Niketan from the Department of Community Resource Management. Today I will be speaking about diseases caused by optical radiation. Introduction. Optical radiation comprises of ultraviolet radiation, infrared radiation and visible light. The natural source of optical radiation is the sun. They can also be generated artificially. Ultraviolet radiation has the highest energy form with wavelength varying from 100 to 400 nanometers. Infrared is also referred as thermal radiation and has the longest wavelength from 700 nanometers to 1 millimeter. Visible lights are seen through human eyes and the wavelength varies from 400 to 780 nanometers. There are millions of people affected worldwide by various forms of optical radiation. Maximum value of UV index is 16.73, which is observed at Bhopal during monsoon seasons, whereas minimum value of UV index is 2.18, which is noted at Srinagar in winters. The study on UV level index in Kerala from 2004 to 2022 shows how often different level of UV radiation was observed. That the lowest level of UV radiation index was very rarely with about 2.11% of the time. The highest level of UV radiation index was quite common with around 46% of the time. The extreme UV radiation index was observed about 33% of the time. Now let's look at the signs and symptoms of optical radiation. Signs and symptoms like sunburns, wrinkles, uneven skin tones, cataracts, dehydration, headache, blisters, dry eyes, eye strain, nausea and fatigue. Causes. The causes of optical radiation can be both natural and artificial. Natural causes include sunlight. The sun is the primary source of optical radiation on Earth. The sun emits a broad spectrum of electromagnetic radiation including visible light, ultraviolet radiation and infrared radiation. Artificial causes include incandescent light bulbs which produce visible light and infrared radiation through a process called incandescence. Fluorescent light bulbs which produce visible light by using an electric current to excite mercury vapor in a tube, which then cause a fluorescent coating to emit visible light. LED bulbs which provide a variety of light including infrared, ultraviolet and visible light through a process called electroluminescence. Laser which produce optical radiation through a process called stimulated emission. Blackbody radiator. It is an object that absorbs and re-emits all radiation that falls on it. It works according to the principle of Planck's law, which states that the higher the temperature of a body, the more radiation it emits at every wavelength. Occupation at risk. Occupations that can be at risk are construction workers, medical professionals like surgeons and dentists, photographers, scientists, welders, employees working with computers, traffic police, farmers, manufacturing workers, and healthcare workers. Now, let's see what kinds of measures can be taken to control optical radiation. Measures taken to control optical radiation are uses of welding curtains. This keeps workers working nearby protected from the bright lights and harmful rays from welding. Put machines like laser or UV lamp inside a protective box. This keeps the dangerous light within the box and prevent any kind of exposure. Avoid unwanted reflection by removing any kind of reflecting tools from the area. Install systems that automatically shut down when not needed or something goes wrong. Proper safety and warning signs need to be used for informing individuals to stay away from the area to prevent any kind of accident. Proper training needs to be given to workers on how to use machines properly. Workers need to be properly educated about the safety procedures related to optical radiation. Proper inspection need to be done to check that the safe system or the machine are working properly and are in good condition. Lastly, let's talk about the ergonomic solution that can be taken to prevent optical radiation. The monitor should be arm length away from your eyes, and the top of the screen should be at or slightly below the eye level to maintain a neutral neck position and reduce strain. Keep the lamp facing towards your desk area to prevent any kind of reflection. Use lamp that can move or tilt to change the light direction depending on the need. Regular eye checkup needs to be done to make sure that the individual vision is good. Personal protective equipment like sunglasses, face shields, and protective clothing are used to prevent any kind of radiation to come in contact with individual's body. Place window facing in north or south direction to avoid harsh sunlight. East and west windows gets bright light in the morning and evening, which can cause glare. Follow the 20-20-20 rule. In every 20 minutes, take a 20-second break and look at something 20 feet away from your screen. This practice helps to relax the eye muscle and reduce fatigue. These are some of the reference links which have been used for the information. I would really like to thank our Professor Dr. Rupa Rao and the Department of Community Resource Management for giving me this opportunity to speak on the topic.